What we see on the screen right now is the basic sine curve f of x equals sine x. You'll also see a slider here, and at the moment the slider is set to a equals 1. What I'm going to do is examine what happens if we change the number in front of sine of x. Currently we have f of x equals 1 sine x, our basic sine curve, period 2 pi, amplitude 1. I'll begin by moving the slider to the number 1.5 and we'll see what we have. First of all, the period has not changed. We still have a period of 2 pi if we look at the peaks and we look at the intercepts. What has changed is the amplitude is now 1.5 rather than 1. Clearly, the number in front of the sine x is changing the amplitude. And we'd expect that if we move a to the number 2, we'll have an amplitude also of 2. And there we are. The next question is, what happens if we reduce a below 1, and maybe not so surprisingly, again if a is 0.5, this multiplier in front of sine x will make an amplitude of 0.5 rather than 1. We'll now explore what happens if a equals 0, and again, maybe not surprisingly, if a equals 0, the curve is simply the curve y equals 0. If a equals negative 1, we have a curve which looks very similar to the sine curve, but there is a difference. To show that difference, I'll draw in a basic sine curve. And there it is. What we can see is that the sine curve has been reflected in the x-axis. The negative has changed the sign of all the y-coordinates. The next thing I would like to look at is what happens if the number in front of x changes. Here we have f of x equals a sine bx. A is currently set to negative 1, which I'll move back to plus 1 to get us our basic sine curve. And b is also set to 1, so this function is simply f of x equals sine x. Let's change b to 2. What we can see is the curve is being reduced in an x direction, and we still have a cyclic curve of the basic shape with a wave function and a period, except in this case the period is equal to pi. In effect, the period has been divided by 2. If we reduce or we change b now to 3, the period, if we check this, would be equal to 2 pi divided by 3. If we change b equal to 4, the period, as we can see, would equal pi by 2. 2 pi divided by 4. We're back to 1 here. If we go to, for example, 0.5, the period has become twice 2 pi, which equals 4 pi. If we went to a negative number, for example, f of x equals negative x, what we see is again the reflection in the x-axis, which is also, of course, a reflection in the y-axis.